This is Reigate College Maths Year 2 Pure 6, differentiating inverse trig functions. On page 3 of the course workbook, we've got 3 standard results in there. For single maths students, you don't need to use these results. They are in the formula book in the further maths section. What you do need to be able to do is you need to be able to prove the results. That sounds like a harder thing to be able to do, but it does fit in with one of the big threads of the Maths A level now being proof. So what we're going to do for each one of these, so these are inverse trig functions. Remember, arc sine of x means sine to the -1 of x, the inverse function of sine. So if y equals arc sine of x, or arc cos of x, or arc tan of x, what we're going to do first is write x as a function of y. Then we're going to find not dy by dx, but dx by dy. We've effectively got those variables the opposite way round from the way we usually do. Then we're going to use this result, which you must remember. It's absolutely crucial. Dy by dx equals 1 over dx by dy. And then usually we're going to be using a trig identity. So if I start with this example 3, if y is equal to arc sine of x, we've got to show this result. So y equals arc sine of x means that x is equal to sine of y. We know how to differentiate sine, so we can say dx over dy is equal to cos of y. Now what we're going to do is we're going to use the trig identity sine squared, in this case of y, plus cos squared y equals 1. So cos squared y is equal to 1 minus sine squared y. You should be very used to that by now, which means that cos squared of y is 1 minus x squared. Okay, x was sine y, remember. So cos of y is the square root of 1 minus x squared. And we need the positive square root here. That's because of the domain and range of these functions. I'm not going to go into detail on that. So dy by dx is equal to 1 over dx by dy, which is 1 over cos y. So dy by dx, using this result here, is equal to 1 over the square root of 1 minus x squared, which was what we were asked to prove. Now, going on to page 4, we've got 2 questions here where we're asked to find dy by dx. Each of these, it certainly looks like we're going to use the results that you've seen on the previous page. So these are not questions that you will be asked to do in your Maths A level. Really, these are much more for the further mathematicians where we use these formulas. I just want to look at question A first of all, because if for single maths students there is a way to do it. In fact, there are 2 ways to do it. One of them we'll come back to when we've covered implicit differentiation, so I'll come back to that in a further video. But one thing that we could do here is we could write x squared is equal to tan of y. Then x is the square root of tan of y, so that's tan of y to the power of a half. We can then differentiate using the chain rule. dx by dy is equal to tan y to the power of minus a half times sec squared of y. We can use a trig identity. Sec squared of y is 1 plus tan squared y. So I've put that on top of my fraction now. I've put my square root of tan y is tan y to the minus a half, so that goes down to the bottom of the fraction. So that's 2 times the square root of tan y. Remember that tan y was x squared, so we can turn that into 2x on the bottom, and on the top we're going to turn it into 1 plus x to the power of 4. And then we're going to turn it the other way up and say dy by dx, which is 1 over dx by dy, so that's 2x over 1 plus x to the power of 4. So that is a way that you could do it using single maths. In an exam for the single maths A-level, you would be given some help with that, some suggestion for how to solve this question. I just quickly want to say something about the questions to do. In exercise 9F, question 8 is a good question to do. And then question 9, A, B and C for single mathematicians. For further math students, all of these questions will be relevant. Single math students, you may be able to do more of question 9, and it will be good practice if you do use the formulas, but it won't be part of what you're asked to do in the A-level. It just may make you more confident with differentiation using these formulas on page 3 of the course workbook, and also the chain rule, product rule, and the quotient rule. These questions using the formulas that we've just seen that are in the formula book for further mathematicians. So for A, we need to use the chain rule. So we're going to say, let's write it down, chain rule. So we're going to say dy by dx is equal to, well, we're going to differentiate the outer function. So remember that to differentiate the outer function, we had dy by dx is 1 over 1 plus x squared. Here we haven't got x squared, we've got x squared. So we've got 1 over 1 plus x squared, and that x squared is squared, times, differentiate the inner function, that's 2x, and that's equal to 2x over 1 plus x to the power of 4. Part B, this is going to be product rule. We've got two functions, product rule. So we're going to say dy by dx is equal to, well, I'm going to take this as u and this is v, so I'm going to differentiate my first one, differentiate square root of x, we get a half x to the minus a half times the second function, arc sine of x, plus square root of x, the first function, times differentiate the second function, and the formula book tells us what we've just seen, that that's times 1 over the square root of 1 minus x squared. Let's tidy that up. So let's do this. So we've got arc sine of x over 2 root x plus square root of x over the square root of 1 minus x squared. I'm going to finish there. As I say, we'll come back to this question 4a when we cover implicit differentiation.